Howdy. This is a presentation by Max Garza and Neil Gokale for Dr. Kate Davis's ECEN 340 class at Texas A&M University, fall 2022. Have you ever wondered how the electricity that powers up our homes and businesses is transmitted across the country? The answer is the electric grid, a network of power plants, transmission lines, and local distribution systems that work together to provide a reliable and stable supply of electricity. Electric power is generated at power plants, which use a variety of methods to produce electricity. These methods include burning fossil fuels like coal and natural gas, as well as harnessing renewable sources of energy like solar and wind power. The electricity generated at these power plants is then transmitted across the country through a network of high voltage transmission lines. At local substations, the electricity is transformed into a lower voltage and distributed to homes and businesses through a network of power lines. In general, power generation works by converting mechanical energy into electrical energy. And there are many ways to do this. For example, fossil fuel power plants generate electricity by burning coal, natural gas, or other fossil fuels to produce steam. The steam is then used to drive a turbine, which generates electricity. Nuclear power plants generate electricity by splitting atoms in a process called nuclear fission. This releases a large amount of energy which is used to heat water and produce steam. The steam is then used to drive a turbine, which generates electricity. Renewable energy power plants generate electricity by harnessing the power of the sun, wind, or other natural sources of energy. Solar power plants use photovoltaic panels to convert sunlight into electricity, while wind power plants use wind turbines to generate electricity from the wind. With the exception of solar power plants, the electricity is generated by using the energy from a fuel or natural source to drive a turbine, which generates electricity. After the power is generated, the power is transported along transmission lines at a very high voltage in order to travel long distances with minimal losses. To make electric power transmission as efficient as possible, transmission lines are typically designed to carry three-phase electric power. Three-phase power is a type of AC electrical power that consists of three alternating currents and voltages of the same frequency, but with phases that are offset by 120 degrees. Three-phase power allows for more efficient transmission of power over long distances because it can be transmitted using fewer wires than single-phase power. This reduces the amount of electrical resistance and losses in the transmission lines. Another way to make electric power transmission more efficient is to optimize the power factor. The power factor is a measure of the efficiency of an electrical system, and it is defined as the ratio of the active power, or the power that is used to do work, to the apparent power, which is the total power transferred by the system. A high power factor indicates that most of the power transferred by the transmission lines is being used to do useful work, while a low power factor indicates that a significant portion of the power is being lost due to reactive power. To maintain a high power factor, transmission lines are often equipped with devices called reactive power compensators, which can inject or absorb reactive power as needed to optimize the efficiency of the lines.
After generation and transmission, substations convert the power to a lower voltage, allowing distribution lines to carry it to other places such as homes, schools, and businesses. The power conversion occurs through the use of transformers, which converts the transmission voltage to a medium voltage between 2 and 35 kilovolts. Depending on the consumer's location, the distribution method will change. For example, in an urban area, the power is predominantly delivered underground, as can be seen in the picture on the bottom left. In rural areas, it is above ground using utility poles, which can be seen in the picture on the bottom right. And oftentimes in suburban areas, it is a mix of both. In terms of the future of the electric grid, as time moves forward, the switch from fossil fuels to renewable energy will lead to drastic changes in electric grid operation. This can be seen in the graph on the right, where renewable energy, which was 4 times less common than coal 10 years ago, will become almost 4 times more common in 30 years. Grid operators will have to adapt to these coming changes, with the volatility of the wind and solar industries, along with households installing their own energy sources, making the approximation of necessary supply and demand of electricity more difficult. These are the references we used for this project. We used CFR, which explained the basics of transmission and the distribution of power, as well as how stuff works, and a Wikipedia page on electricity generation. I hope you enjoyed this presentation. Thank you.